The FASTAP project aims to install a very innovative on-load tap changing technology from the real-scale test bench all the way to the wind turbine prototype in order to see the commercial applications that this innovative technology has in the wind sector. FASTAP consortium is made up of 4 different companies. Initially, Mondragon University is the owner of the technological seat and is also responsible for the real-scale test bench testing in the FASTAP prototypes. Infineon is the expert in semiconductors and the expert in thyristor technology. SGB is the expert in transformer manufacturing, both in dry type and in oil immersed. And finally, Siemens Gamesa, we are the experts in wind turbine design, and we are responsible for integrating this new prototype with this novel on-load tap changing technology inside the wind turbine.
The main characteristic of the FASTAP technology is that it regulates the LV side voltage. And for that, the FASTAP technology uses the actual hardware in a wind turbine as it is. So the main benefit of it is that it regulates this voltage, but not only that, it regulates that voltage using the same hardware. And so this means that the FASTAP is a plug and play, a new add-on that could be added to a wind turbine without the need of major changes on it. One of the main benefits of the electronic OLTC technologies is that you can adapt your OLTC to specific places or circumstances. So it's completely scalable, adaptable, and very, very versatile. Big groups of difficulties or challenges in this project. One group could be formed by the external challenges that obviously have affected other people, but to us have affected the coronavirus, the raw material crisis, the Ukrainian war. All those different events, worldwide events, have affected, let's say, have increased the challenges of the FASTAP project. And apart from that, we have had inner challenges, of course. One of them is the lack of standards for testing this technology, because it is an ice-breaking technology, so there's no path to follow for doing the tests. And another one is, and which is related with that, the lack of the test rigs for testing this kind of equipment. So due to this lack of test rigs, we had to develop our own test lab for testing the FASTAP technology. So that itself was a challenge.
FASTAP technology transformer has been already tested different tests in third-party laboratories as well as in the Mondragon University test bench. So now it's time to put it in the real turbine. So now we have a Cener-Alaiz prototype. We can put FASTAP transformer there, and we can check and we can monitor during the 2 and 3 months for the operation, and we can check our FASTAP technology is working very well, integrating in the real turbine. For that case, firstly, we need to arrange a logistic team. They are loading transformer and unloading in the Cener-Alaiz Wind Farm, and they are going to use the special crane to lift up the transformer and to put in the turbine. For sure, the transformer will be located in backhand in the nacelle. So after that, our technician in Siemens Gamesa will do the all installations in the nacelle, and they will for sure arrange the cable installation, and also they will do the FTCU connection in the converter unit. In that case, then after that, when they finish everything, they will do they are going to check the system is working properly before the commissioning. And after that, they are going to start first energization on the turbine, and then they will be able to check operation of the FASTAP is working properly.
From the electrical perspective, the FASTAP has two main capabilities that are totally differential from the current state of art in the industry, in the electrical industry. One of them is the speed of their voltage regulation capability, that is capable of doing a voltage regulation within 2 electrical periods, so less than 40 milliseconds. And secondly, the amplitude of the amount of voltage that it can regulate. So it's not only a very fast technology, but it's also a technology in which you do not have boundaries from the electrical perspective to regulate a big amount of voltage in very little time. The final goal of the FASTAP project at the end is to increase the possibility to integrate more renewable energies in the electrical grid. So at the end, what the FASTAP aims to do as a last goal is basically to ease all those projects that did not have an easy grid connection point and allow for projects that were not economically viable to be possible, no? And to have another possibility to integrate more renewable energies into the electrical grid.